Might have a chance. Cha! Yeah, right. Hi, I'm Carlin. Thanks for checking out my video to my electric bike project that I'm naming Turtle. I live about 15 miles from the nearest town, where the post office, gas station, and civilized people live. In April, I sold my truck, leaving a broken down motorcycle and a couple of bicycles. What you're about to see is my attempt at building an off-grid DIY survival quadracycle, a pedal-powered microcar with electric solar assist. I did a little research, but my way is most likely not the best way to do this. Once a week, I ride a bicycle into town to check mail and packages. I like bike riding, so I'm kind of looking forward to trying this out. That's the plan anyway. Stay tuned and be sure to subscribe if you're interested. I just wanted to get a quick shot of what these look like. So these are battery packs, battery modules. I already opened one up. These are 26 650 instead of 18 650s. Okay, for the sake of scale, I've got flashlights that use these. This is what they call an 18 650. If we did this in metric, it's 18 millimeters by 650 milliliters. These are 26, so they are bigger in diameter but the same length. A couple of notes while I'm thinking of it. Laptop batteries are usually made out of these. Flashlight batteries, people that are doing vaping, electronic cigarettes use these. And a lot of Tesla cars are made from these, but I'm not sure if the newest ones still are. This is how it was when I bought it. Comes in this plastic box. I got these for $10 a piece, and I got 20 of them. Each one of these has 8 cells, so that gives me 160 of these cells. Electric bicycle project coming up, I'm going to be running 48 volts on the motor. So if I could take 4 of these together, wire them in series, I would have 48 volts. Including shipping, I got 20 of these packs for $330 altogether. You know, what I need to know is how many dollars worth of batteries will get me 100 miles. And I'm expecting that I could probably recharge these somewhere between 200 and 1,000 times. Yeah, I'm going to resist the urge right now to just rip them all apart, because I might figure out something that I could solder into and then be able to use these again. So what I'm doing here, I got 2 of these battery modules opened up. Each side is 12 volts, so you actually get 24 volts approximately out of the end of this. But what I figured out is this point right here, there's a silver pad here and here, a solder pad. That's the end of the batteries, and I can pull 26 volts off of here and ignore this. That's the cool part. Is when you're soldering on here, these are very, very close together, and I have arced and sparked all over the side of the other one here. If I flowed solder across the wrong spot, I would have a dead short. This can put out about 60 amps at 48 or at 24 volts. 60 amps, you could weld with that, right? Yeah, this could literally weld. So yeah, be careful with that. On this one, I've got 2 leads, these red and the black here, soldered on. And I'm taking some weather stripping and just putting a little bit on the end here, and then I'm going to put the 2 side to side. I can't imagine this is going to work that well, right? So, but in the meantime, a little bit of this, I just got to try it out. So if I can get this to work, so I'm basically going to hook the 2 in series, just a little bit of padding. If I can get this to power the motor, and then we can start a benchmark. How many of these batteries do I need to run the motor? And I did actually put the safety glasses back on. Might have a chance. Cha! Yeah, right. I just thought about this a couple days ago, and I've got so much more room out here that's not really being used right now. So I thought, let me move all the battery stuff to here. I can build and test and charge battery packs out here. One of the biggest problems with this always is when I'm doing a temporary kind of a rig. I'm I'm always kind of in danger of bumping something and then I get a short and sparks and then you freak out. So what I'm going to do, these three batteries are very close in power. That little bump is a magnet. This one there, you can see it. That is magnet. That's not part of the battery. You can kind of see it moves around a little bit. So these little strips of metal are magnetic and conductive. These are the strips that I will make the batteries out of. I will basically weld these right across the front of the batteries. I'm connected with the strips, hook the alligator clips up to the end of the strip, bring them up in power. So the trick is I got to get them matched first. Once they're matched, because like if this one is fully charged and this one is empty, if I hook up a strip to them, it'll have just a massive amount of power flow from the full one to the empty one. When I get them all matched or close enough, then I can hook them all together, hook up the jumper leads to the wire, and then use this to bring the voltage up. And then I can check them. Once they're all at the same voltage, then I can start welding them together. Alright, so we got, these are 24 volt packs, and I got them pretty much matched. One is 26.66 and one is 26.46, something like that. A lot of this is really tedious work. I'll just say that. You know, but at the same time, you got to do it. You got to be careful. You got to be methodical. I'm going to put that aside because it's all ready to go. That'd be nice. Yeah, there's a bunch of these are fully charged. So the next part of the plan here, because I'm making this up as I go. I'll just say that. Okay, if all of those are the same volts. Okay, hang on. That feels really good though. I'll come back to that. Okay, so the plan is the batteries that are over here that are all taped and spot welded together, these are joined up, so these two are the negative and positive, and then the negative and positive. 24 volts, 24 volts, that's 48 volts. That's the minimum I can run the motor with. Okay. That would probably not get me to the gate and back. Okay. What I need is to go through and start popping them all off and assembling packs like that. However, I don't necessarily need every battery that I own combined into a 48 volt pack. Okay. I'm starting to see that there's reasons for not doing all of them. For example, I might decide to take some of these and run my little radio from it. Okay. That would be probably 3 or 4 of these would make a nice little pack. Okay. Sweat's running in my eyes. On the other end of it, if I make a go-kart, I'm going to need a lot of these to do that. Okay. But what I'm thinking is it would make sense to make medium-sized packs that I might have 3 or 4 on the go-kart, 2 on the bicycle, 1 on the skateboard, something like that. But I only have 2 of the battery management units because they're $70 a piece. Okay. That made sense because this is the solar charge controller that I'm going to use for testing at least, and this can do 24 volts. Okay, David actually gave me this one, he wasn't using it. So what I'm thinking is taking some of my solar panels, hooking it up to here, taking a few of these battery packs, running them through here, so I can have solar charging these guys completely separate from everything else for now. Let's say I go check my mail once a week. So I'll take some batteries, put it on my little mobility scooter or whatever I end up with, ride to town, come back when I get home, plug it in. Now it's only going to get about 2 hours of good charge the rest of that day. But the next day it'll have a chance and get more charged, and then the next day it'll get more charged, you know. So if nothing else, by the end of the week I've got enough of a charge to go get mail again. And if that's what these are for. But in the meantime, those batteries could also be powering the house. That's kind of what I'm thinking is this gives me more batteries that I can run laptops with. If I put these all together on a system like this and put 24 volts in, we'd have a fire in no time, in theory. Now I haven't experienced that very much yet, You know, I've gotten sparks out of these because I bumped something, but I haven't had one blow up yet. 249. So those two are really close. Okay, I'm confused now, right? Because these should have been, unless I just completely buggered it up when I hook things up. It's a possibility. I'm wondering now, it's like now that I've taken it all apart, but I had 48 volts coming out of this thing. What I'm seeing is one side got ran down and one side was fully charged still. That does not make any sense at all. Okay, that makes my job easier though. So these ones I can solder or weld together into a pack. I'm going to do that tomorrow or the next day. So like now it's getting hot. It's 103.6 according to that little digital thing over there. So I'm feeling it, but it's not too terrible, and I think I'm going to just stick with it for a while. I have no idea what time it is. I don't have a clock, and I quit wearing my watch a while ago, but I'm just going to chill out here. Got my fan going. At least now that the sun is coming out, I got power. Doing something. This is the 5th of July. So I don't remember when the last time was I did this, but it's been a few days since I was over here. This didn't take very much power, although the spot welder did knock the inverter off about 3 times today. It works just barely. Honestly, it's not... It's like these little strips. It's welding them onto the batteries. And the idea is these batteries are very sensitive to high temperature. So if you sat there and soldered onto here, you would probably screw up the battery. Okay? I have serious doubts about that on the road, bouncing down the road, if that's going to work. So we'll come back to that one when we get there. But for now, I need something that at least works well enough when it's sitting still that I can start testing until I get to trusting these a little more. Now I know the batteries themselves are relatively safe because they were used in professional, these are all used batteries, so they came off of working equipment. So in that respect, they work, but I've completely removed all of the safety protocols. Yeah. All right, let me get started here. So they're just out of reach. So I'm sticking, this is one of the other reasons for being out here. I have so missed this metal ceiling, you know, so I can grab these little magnets off of the ceiling because it's just, I can just reach it, you know, and I use the pliers because it's sometimes hard to grip these things. Okay, so I need to get this up to 3.3. Some magnets are strong enough they'll grab something from, it seems like a long ways away, but at least 6 inches away. Okay, 2.0. And yeah, I know I talked about this before. Ideally, I would have a standalone purpose-made charger for these batteries, right? But the way I'm looking at it is what I'm doing now is only a short-term situation. I'm not going to be dealing with individual batteries very long, hopefully. Once I get these things all assembled, sweat everywhere, then they will become a pack like this. They'll have their own electronics built in, so all I got to do is put power into them and they will do whatever it is they're supposed to do. That's actually kind of perfect for me, honestly. You know, I do a lot of fiddly stuff, it seems like, so. These guys, I think, will serve me well. You know, for what I need to do, I think they'll work really well. So I got lucky, I guess, in that respect. Just the amount of energy they seem to be holding is very encouraging. Just, I got to remember to slow down, have some patience, work the system, little bits at a time. Everything gonna be okay. It's got to be quitting time, right? Alright, so the original two 24-volt packs are there. This one had lower than full voltage, but 3 others had full voltage. So what I did is I opened up, took the cases off 4 packs, decided to just focus on the 3 that had full voltage. So these ones are all either full voltage or charged about 3.2. Just started getting tired and I had 2 pretty good sparks. So I'm like, yeah, it's a good time to quit. Anyway, So what I'm thinking the next day, if I get a BMS on these two and make them both 24 volt systems with BMS, yeah, that's probably almost as awesome as it looks. So 4 cells, so I'm running this in 4S lithium iron phosphate, and the colored leads, the yellow, the green, and the black, are balance leads. There's a big red and a big black that are the main power leads, and these are all held together with little magnets and then the nickel strips. So I drop a magnet on each one, and then I just connect the strip across to make a temporary connection, and then the alligator clip just magnetically sticks to the magnet. And that's about as good as it gets. Quick wrap of electrical tape to keep everything in position. So I'm just kind of doing this for right now for testing. This is a fairly well-known, maybe not well-respected battery charger. This particular one has the built-in AC charger. Typically you'll see one of these that is just a DC end to a battery charger. So you could plug it into your batteries, like if you're out at the field flying your radio-controlled airplane, you could plug this into your car and use it to charge your airplanes. That's kind of what it was made for, I think. Any of these lithium batteries, though, you have to use some kind of a balancing system. All right. For instance, this one here is a pack that is soldered or spot welded together, but I don't have any balancing system on here yet. But this thing, as it sits, is 24 volts. So what I would need to do then is to connect all these leads to individual points so that the charger can keep track of it. Like, this is all just monkey rigged right now, but when I solder these leads to here permanently, then I could have myself a system where the little control, or the little pigtail here, would be part of the battery. So I would just plug it in and then plug in the main power leads. If I have one battery that's defective, it will pull my average down. So if I have one battery that's 2 volts and one that's 3, and one that's 3.5, and one that's completely defective and not working at all, if I hook them all up in parallel, they average to whatever those numbers add up and then divide by 4. The power supply sees that and says, okay, it's about 2 volts, so we crank it up, send in 2 or 3 amps into it. The one that's not working at all is pulling down the average. The one on the end might be overcharging. So I kind of got to watch that. We've doubled productivity here. So this is the new one. Outside they look identical. I might have missed a setting somewhere, but this one does seem like it's doing something different than this one. I'm not sure if that necessarily means anything, but oh, it's always good to have your propane tank right underneath your lithium batteries when you're charging, right? I was so careful out in the shop, I moved the gas cans out of the way. That would be my luck. Alright, so this is the battery management unit. Literally, it manages the battery. These wires are the balance leads. These wires are something else. I'll come back to that in a minute. I am not the expert on this, but I have been reading and trying to understand. So this was something I found on eBay. It's about a $70 unit. This can do up to 16S. So in this configuration, this is for 8 in series, so that would be 8S. Each of these batteries is about 3.2 volts. So if you do 4 of them, that's about 12.8 volts at 3.2. So if you do 2 of them together, it would be basically considered a 24 volt pack with a couple extra volts, right? This end is B minus, so this will hook up to the minus of the battery here. This is, what do they call it? Battery first. This is the charge minus, or the load minus, I guess. So basically this goes in line between the minus of the battery and the minus of like your motor or your charger, your solar system. It's not as intuitive as the way I would normally think about it, I guess. These wires go to individual batteries on here, for instance. I'm going to get these out of the shot just to cut down on confusions. There's a red on one end, so that is the positive most one, and so that would go on the positive lead. I would just, get soldered on there or something. And then the next battery is the next wire, and so on. But because I'm only using 8 wires, 8 batteries, and this is rated for up to 16 batteries, we're going to skip a few. So it'll basically be starting from this end, we'll do a few, starting from this end, we'll do a few, and then the ones in the middle we'll skip. That's part of why this is taking so long, is I keep looking at this and I'm like, 1, I'm confused. 2, I don't really know exactly some of the processes, so I'm trying to figure it out. 3, I don't need a 48 volt system most of the time. I need it for the bicycle though. So I'm trying to get my head around which makes the most sense. Can I make 20 or 12 volt packs? And so I've actually ordered, in addition to 2 of these, I've ordered 4 smaller systems like this, the battery management system, that I can run with a 12 volt system. You can't mix a system like this plus the lead acid batteries you already have and try to combine them into one system. So yeah, it's not really neat and tidy because I'm trying to do 2 or 3 things at the same time. That makes it more complicated. Okay, and now we're going to work from the next positive. And so this is kind of the trick, I guess, is you just look at the order of the wires in the ribbon and you just take the next one. BMS C ground is going, that's the charger side, that's going to the power supply. B ground is going to the ground negative terminal, the most negative of the battery pack. Positive from the battery is going to the power supply. So that makes a circuit. Okay, this isn't turned on yet, and this isn't turned on yet. Voltmeter on, power supply is off. I should have about more than 24 volts here. I do not. Oh wait, no, because this isn't turned on. So I shouldn't have any power on here yet. This is good. Okay, so if I turn on the power supply, it should show no voltage. Yeah, because this is turned off. Okay, we're good so far. So the way that this works, to power it on, we take these 2 wires. There's a little red and a black here. We just energize it for 2 seconds off of a single battery. I don't know what the limit is, but apparently a single battery is enough to do it. So I'm going to just use this one and hit it across the leads. So we'll count to 2. Okay, ready? 1, 2, beep. Okay, I think this is working. The light is flashing. It doesn't tell me anything about what that's supposed to be. The instructions say this will also start up when the charger starts charging. So I'm going to just put a little bit on here and see what happens. This is expecting more batteries, so I should get that part figured out first. So I am going to turn off this and find the app for that, which I should have already, but... Okay, sometime later, and after eating a snack, there's all the settings on the app, and here's an actual readout of the batteries. With this connected, I should be able to turn the power supply on, and it should read voltage coming out of this. Which it's not doing yet. Unfortunately, a lot of what I'm seeing here is in Chinese. It doesn't make it easier. I don't know, it's close. I think we're close. At least we got it to connect to the app. At first I couldn't get that to work, so... Got a lot to learn here still. One of the issues... And look at all these lights flashing now. I hadn't gone into the basic parameters, and I don't know if this is... Okay, so you get an idea. There's a lot of stuff here, right? Okay. So it was saying batteries or wires disconnected. So I finally find there's an option for actual connected cell number. So it was thinking 16, and there's only 8. So it was saying, yeah, there's a bunch of wires disconnected. So I need to get through and tweak a bunch. There is like literally pages of settings here, right? But because I bought these batteries used and as a series of modules that were already built up to something, so then I take them all apart. Anyway, so what I'm doing now is I'm looking up the batteries on the internet to get the actual parameters for them. I started off with a preset. Crap, I'm still going. To get me in the right voltage range. Okay. So the charge and the discharge MOSFETs are open now. Auto balance is on, so it's balancing now. Cell, the highest one is 3.297 and falling. The lowest one is 3.280. It's about 35 to 36 degrees in here right now. Okay, now that that's turned on, I just want to see, this should show me 26 volts on here. Yes, it does. Excellent. Okay, this thing was turned off. It was like not letting power flow through it. So it was reading all of the internal stuff, but not letting power go through it. Now it is. So I'm going to just put some power into it and see what it does. So it's at 26.3 now. This can only put out about 30 volts, so it's about maxed out. I don't think I can put enough power out of this to actually do anything. So I guess the biggest thing now, because this knows how many batteries it is on here, it's not freaking out, so it's at least that's working. And start making sense of all of these. Yeah, I got some time to go. Yeah, it's kind of cool. It's got a bunch of lights going back and forth that shows that there's activity on the different wires. I guess what I'm thinking right now, the reason I brought it in here is I want to be able to do some like video editing and stuff like that. So while this is sitting here, I can be sitting close to it, so if I start smelling smoke, I'm at least close enough I can grab the thing and throw it outside in the sand pile or something. I mean, okay, you buy something from China. I've heard Chinese people say this. They're good at manufacturing, but they aren't really good with software and instruction manuals and that kind of stuff. But the thing is, this type of device doesn't really exist off the shelf anywhere else but coming out of China. I have put this part off for a couple weeks now, honestly, because I was just you're like, do you really want to get started on this? So here we are. Today's the day. Okay, 218. The system shows 26.1. 26.0, 26.1. So 26 volts coming off the batteries, going through the step-down converter. That's putting out about 13.5 volts or so. I got this measuring the main batteries for now. But that's going into 300 watt inverter to the cord. I'm going to run that into the big laptop and do some editing. And I just want to get an idea how long I can run that. And I'll keep an eye on the phone. Also, what's cool is I can use the app on the phone to shut off the output. So essentially taking power away from the inverter, which is kind of slick. It's kind of the other way of doing it. So I can turn off charging and I can turn off discharging. I'm not sure if that quite makes sense, but I think it does. I just had to stop and think about that for a minute. But yeah, you can turn it off. It's like, okay, that's kind of cool. I'll get some editing done, because I'm not getting anything else done anyway. Whoa. Yeah, the inverter chirped pretty good when I first plugged it in, but it looks like it's running now. 26.0. Oh, it's showing an amp finding. I haven't... This is kind of interesting. That's showing 0.1 amps, 2 watts. Yeah, so it's showing a load at least. And cell difference too high. Yeah, we just lost it, which is weird because I got lots of power. Just not the difference is messing me up. It's kind of cool though. I'm seeing real-time voltage changing on per cells. They're definitely not staying balanced though. One of them is way low, 3.0 and dropping. Yeah, the one that was the low cell isn't the low cell anymore. This will be important because there's nothing in the BMS that's going to help the cell stay in balance. Yeah, one is just crashing. Wow. Number one cell was dropping 2.5 instead of 3.2. Okay. And now it jumped right up to 3.2 again, so that one was crashing. Yeah. Of course, this was built up out of not the good cells. I just dropped right off. It just reset itself though. The BMS reset itself, but the inverter didn't. This means I'm going to need to spend more time matching the cells to get usable packs out of this, I think. I wonder if this is trying to balance on its own, like propping up the bad battery. Maybe that's what's keeping it from going offline. 24.2. I'm going to just let it run until it faults out, and then I'll go back to running it off of solar, because I got plenty of solar. Yeah, and enjoy my fan. Interesting test, though. 14 minutes in, I think that's how long it's been running. It's not very good, but it's interesting.